Okay, well, I'm going to start. Is that a good idea to start?
Yes, please.
I'm going to share my screen. These slides are in your folder. So if you want to download them from the folder, you can download them from the folder. So they're in their interactions PD. They're in the interactions folder, and it's titled Consulting Session January 11th, 2024. So I'm just going to go a little bit over the interactions curriculum, but I'm going to talk more about what I would do with respect to professional learning. So this is sort of a model I have of teacher learning. It came from a publication I did several years ago. And if we really want to get teachers to change, it's really an interaction between
Destek mata mama.
it's really an interaction between us as science education leaders and them as teachers. So as a science education leader or a science educator, I bring things to the collaboration with me. I bring new possibilities. I bring a vision. I bring strategies. But teachers bring other things with them. Teachers bring things with them as well. They bring some realities of the classroom. They bring their curriculum. But if we're going to bring about change to improve science teaching and learning, it's really a collaborative effort where we inform each other, we share, and we critique. And of course, a critical aspect of that sharing, so we've been sharing for a good couple of months now, but now eventually we have to get to enactment and planning. Because otherwise, those visions that we have, those new possibilities, those new conceptions of science teaching and strategies, we won't see how they play out in the classroom. So it's really important that we've been collaborating, we've been sharing, but now we need to go to the point of enactment. We need to plan and build. And of course, once there's some enactment that happens in the classroom, we should go through some reflections about how did it work, it did not work. And so we're at a different place right now in the professional learning compared to where we were, you might say, a couple, when we first started this, right? So we're now at a place where we've done a lot of sharing. We've shared some visions of science teaching. There's potentials to look at some videos, particularly with respect to interactions. But now it's really up to you guys to start to plan how are you going to carry out your professional learning. The teachers have to plan how they're going to enact this in the classroom, and then we have to reflect. And of course, we always want to keep in mind as we go about doing that these materials, these new visions that we hope are somewhat concretized in the materials are, have to be played out with some degree of fidelity. You're going to have to modify them for your particular environment. But unless we try to use them with respect to some degree of fidelity, then we're really not going to see if they really work in the classroom. So I've been involved in my life in a number of these efforts. And if you only do it, if you only do it once a week, or if you really don't do it, you sort of do some parts, but not other parts. Then what happens is you really don't get a sense of, do these materials really work? And this is one reason why in education, we constantly fall back to the old way. So instead of saying, okay, we know that there's evidence for why we want to engage kids in meaningful contexts. We know there's evidence for getting kids construct models and evidence-based explanations. We know there's strong evidence for kids working together and trying to figure stuff out. Instead of trying to keep perfecting that model, we fall back to our old model. And if you think of any engineering situation, if that was the case, we would never make progress. We would still have horses and buggies. Now, maybe having horses and buggies might be a better thing nowadays, considering all the climate problems we're having. But the point is we don't improve on something unless we reflect on it. We have a model, we have a vision of where we want to go, and we really try it out, and then we reflect on it. And that's where we are right now. We're really at and I know some of you joined the project late, but we did a lot of sharing already, and we did a lot of curriculum. And so the curriculum now is for you to really carefully go and take a look at and really try to enact in your own classroom. So that's where I see we are in a cycle of teacher change and teachers implementing new materials. And if you like, I can certainly share this manuscript with you. It's an older manuscript. I actually wrote it when I was a long time ago when I was an assistant professor, but it's still a vision that I hold true today when I work with schools and teachers in schools about how do you really bring about educational reform and change. And if you have any comments or questions, please feel free to put them in the chat, or raise your hand or speak out. I certainly won't be offended if anybody just speaks out. So just feel comfortable speaking out if you have a question, or place it in our chat and I'll respond to it. And the vision that we're really trying to share in all three of these curricula, and we have other ones to share too, if for instance, if it doesn't quite work out, but the three that we're working with, the water quality unit, the health in our hands, and interaction, really do have a different vision about what should happen in classrooms. And one of those, it's all started by kids experiencing some form of a phenomena that exists in their world. When we're working with Anne, the phenomena is related to water quality and how can we keep our water quality safe to drink and safe for the environment. In the Health in Our Hands project, we're really looking at what causes various kinds of diseases and how does our genetic makeup and our interactions with the environment influence how we express various kind of features, including aspects like type 2 diabetes. And in the Interactions project, we're all about trying to help kids figure out why materials in our world stick together. If it's why does water stick together at room temperature so we have a liquid, but when it drops below 0 degrees Celsius, we have a solid, and why at 100 degrees we have above 100 degrees we have a gas, if we're at standard temperature, standard pressure. And so it's basically looking at why do materials stick together? Why does a piece of plastic sometimes stick to our clothing? What holds materials together in the first place? And so it starts from a very simple phenomena of looking at why a sock can cling to us once we take it out of the dryer, or why does a piece of plastic stick to us with it? Sometimes the pie pans flying off, what causes that? So there's always some phenomena, and we as a team really feel it's very important that once kids experience a phenomena, that should give them an opportunity to raise related questions. And one of the comments that was in the chat yesterday was that typically the teachers ask the questions. Yeah, I get it. I was a teacher too. And typically the questions we ask are all about does the kid know a particular part of content? But this is different. This is kids raising questions about the phenomena that they experience, trying to create a situation similar to what scientists do, right? Scientists are ask questions about why does something occur? What's happening here, right? Would it happen in a different situation? Do all liquids evaporate or boil at 100 degrees Celsius? Why do some boil at much lower temperatures and some boil at such more higher temperatures? So if we get kids to experience some phenomena, then we want them basically to raise their own questions. And one of the important points that we raised yesterday, and I believe Ann raised it too, is that in order to help teachers understand why we need this new approach, is because if kids ask their own questions, it helps them develop motivation to want to see this stuff get answered. So really, if you create a context that's interesting to the kids, that allow them to raise their own personal question, that actually leads to kids being very effectively emotionally engaged. And emotional engagement is a prerequisite for kids really being cognitively engaged. So they really want to understand a compelling mechanism. So that's why having kids ask questions is so important. It's all related to, can we create a situation where we can emotionally engage the kids? Because that emotional engagement, that interest, that spark, that wonderment, that are all related to emotional engagement, that all leads to kids wanting to get cognitively engaged. And of course, then in our model, that really leads to kids doing investigations, kids constructing models, kids using various scientific practices, other scientific practices like analyzing and interpreting data, writing explanations based upon solid evidence. And of course, like any good, that process then leads to a little piece of new knowledge. And it's not that we think kids are going to rediscover the structure of the atom or rediscover the structure of how the human body works. So there's certainly times when we have to give little informational talks that can, just like I'm doing now, I'm giving you a little informational talk. It's important. So at times we have to do that, but basically these situations allow kids to figure things out on their own. Very similar to like when we did the baggie experiment related to writing explanations. It wasn't me who said, when we mix things together, sometimes you can form new products. We experienced that through the baggie experience. And so kids get to realize that, oh, sometimes when I mix things together, nothing much happens. Sometimes when I mix things together, something might dissolve, but I don't necessarily get something new because I can let the water evaporate off and I get the same thing back. Other times when I mix things together, I get something brand new. And that's that conclusion the kids can come to at themselves rather than me as an instructor really telling them that. So this vision of science teaching and learning is very different. But we know and as I presented in other sessions, we know there's solid evidence that really shows that this improves achievement over other environments. We also know that it really causes learners to be more interested in science and want to go into science. And of course, that's one of the, we as nations, we face both those issues, right? We face kids needing to have deeper knowledge of science, but at the same time, we have to have them being interested in learning science. If they don't care, then they're not going to go on. And then as a nation, we're stuck in the same position we always are. So this is the vision that all three of those curriculum, those are the vision. This is the vision that drives the interaction curriculum. And given that vision, and then given that instantiation of this vision in these materials, it's our job then to say, okay, how can we work with our teachers and our nations to try these materials out and really get them to use them, and for us then to see how it works in our nation and how does it compare to when they don't use these kind of materials, right? I mean, that's the big test. We always have to put out a test. What I have is I have really strong data from the United States that these kind of curricula can work. In fact, our whole nation is driven by designers and school systems and school districts and teachers trying to implement this form of vision. Many of you may know that I do work very closely with Thailand, but I also work very closely with China. And China has actually adopted this model in their national curriculum because they see the value of it. Now, it's going to take a while, just like it's taken a while for the United States to really implement this vision in their classroom. But as a nation, they're saying, we're going to go forth and try this. And people now in China, science educators in China, are having teachers implement units, and they're studying those units compared to other units. I was just working with a young scholar from Beijing Normal University, and he's designed a middle school series of materials that focus on middle school kids understanding energy. And his small study, it was a small study, well, not 650 students with a couple of teachers. Those students did substantially better than a comparable group of students on assessment tasks and their interest in science. So there's evidence not only from the US, but there's evidence emerging from other parts of the world that classically don't use this form of teaching, right? The reason I raised the example from China and how China is actually building these ideas, the use of really trying to create rich context through driving questions, students experiencing phenomena, kids using scientific practices. It's just China has now embedded that into their national standards. And so given that they have a national curriculum, they can push that forward. And so we have to, and then they can try things out in the classroom. This is what we have to do with our own school systems in our own districts as well. We have to try these things out and say, how do they work? And hopefully we'll be pleasantly surprised, just like I was always pleasantly surprised. But there's good evidence from other places that these things work. And so your job now is to say, okay, how do I take these materials from interactions? How do I take these materials from health in our hands? How do I take these materials from the quality unit, water quality unit, and make sure I can implement them with a degree of fidelity so we can really see what happens? And I realize that there's going to be challenges in every nation. We all have slightly different standards, but some of the big ideas are still the same, right? The big ideas, understanding what can pollute our ecosystems is a big idea, and how can we keep our ecosystems healthy is a really big idea. And so how do our genetics interact with the environment? Gene environment interaction is a big idea. And these ideas have to develop across time. So our nation should all focus on those big ideas. So that's sort of a preamble of at least what I see, what we're trying to do in these consultation sessions, or where we are now that we're starting these consultation sessions. We introduced you to the curriculum. We introduced you to the evidence-based principles underlying the curriculum. And now you need to step in and say, okay, how do I enact this? What do I do in my own professional learning to make sure this occurs? So I wonder if there's some questions. It looks like someone's electricity went out. Is that correct? I don't know where that came from. The comment says, same here, no electricity. I'm sorry that there's power outages can always be a hassle. I hope it's not too serious. Are there any comments or questions before I go on? Okay, so one of the, when I enter professional learning, or when I stop to think about professional learning, one of the big points that I always say to myself is what's really new here, and what really do I have to help my teachers if I'm the professional development leader? What's new here, and what am I really going to have to help my teachers understand in order for them to successfully implement these materials? And then I move forward from that. So I always try to make a list of what are the critical ideas, and how then do I move that forward? So when I look at the 3 units you're to enact, obviously one of the big differences is the driving question and initial experiencing of the contextualization. We typically don't do that. And so I know I really have to support my teachers. And of course, one of the questions we can ask ourselves is, how can we do that? I do that. We do that here in Create by actually putting the teachers in the situation. This is what Consuelo talked about yesterday. I believe Ann talked about it as well. We sort of put the teachers in the situation where they actually experience the phenomena themselves and can raise questions related to the phenomena. The same thing is true in the interactions curriculum. We start off by actually having the teachers experience the same phenomena that the students would experience, and have them ask questions, and then we're able then to introduce the driving question, so that in the first unit we actually have it's driven by this question: why do some things stick together when they come out of the dryer? And so that's the big question. In unit 2, it starts off by, how come a tiny spark can cause a huge explosion? So we start off by having, in the professional learning, the teachers experience those phenomena, so that in fact they can ask their own particular question. So in the first unit, in interactions, why do some clothes stick together when they come out of the dryer? We start off by having the teachers actually experience that same phenomena where they observe the pie pans flying off of the electroscope, not the electroscope, fly off. And then based on that, actually ask questions. And so I always say to myself, because I know if they can understand the driving question and getting kids to ask questions, that's going to generalize to the next unit and to the next curriculum materials as well. So that's why I like to pick these, what are these big ideas that, within a unit that I know kids really have to generalize, will really need to know, and they're going to have to generalize to other materials as well. Consuelo stressed that yesterday, and stressed that in her particular presentations, and I'm stressing that as well. So when I look at these materials, including interactions, I say to myself, what I have to help the teachers understand: why have kids first experience phenomena? I have to help them understand what's the reason behind that. I have to put them in that situation so they really get that experience. And of course, when I can combine all those 3 things, I'm actually starting to build some important knowledge structures in the teachers themselves, just like I want to build those knowledge experiences in kids. And so having them experience is so critical, because just when I sit here talking like I'm doing today, it's just one way of portraying information. And we know that that never really works. What we really have to do is put kids in a variety and teachers in various situations where they can experience things in multiple ways. So I'm certainly going to speak about the value of the driving question, but then I'm going to have them actually and the importance of experience and phenomena. But then I'm actually going to put them in a situation where I really want them to experience the phenomena, ask their own question, and then me post the driving question so that they can write their own questions and put it on the driving question board. So when I look at these various curricula, when I look at interactions, I say to myself, okay, that's one of the big things they have to understand. So that when I'm planning professional learning, I have to get them involved in actually doing some of the lessons. Now, it's impossible within professional learning to do all the lessons. You can't. So you have to pick out some of the big important parts for them to experience that can generalize, and then hopefully it will be useful for them in the next particular, as they go forward in that unit. When I look at interactions and when I look at health in our hands and I look at the water quality unit, and I say to myself, what are, outside of just in addition to understanding the driving question and the experiencing phenomena, what else is really important that the teachers probably don't have experiences with? And then I say to myself, oh, well, they really have to understand modeling. That was brought up actually is one of the points yesterday too. We have to put students, the teachers, in a situation where they actually construct a model along with their colleagues to explain a phenomena. Because when they do that, they get to see the value of why what's so critical about building models. And when you put them in groups to build models, you actually illustrate two important points. You illustrate how do you build models where they realize I have to identify what are the objects and variables in my model, what are the relationships in my model between those variables, and how does that set actually explain the phenomena? When they're sitting there working together side by side, they get to experience not only the value of creating a model to form deeper subject matter knowledge, but it also shows them the value of working with colleagues, with students working together, because that discourse, that interaction, that talking with each other about ideas rather than a monologue like I'm giving right now, dialogue really helps people form ideas. Similarly, the same thing is true with constructing explanations. I have to give, because I know my teachers don't have experience constructing explanations, I have to put them in a situation where they will collect data, and based upon that collection of data, they can make a claim and show that they really have the appropriate and sufficient evidence to support that claim and the reasoning behind that. And unless we put teachers in those situations, then they're not going to know how to support their kids in the process. So I always look, my first point in planning any professional development is always saying, what's new and what do I got to help teachers understand so they can implement it in their classroom? And I tried to point out at least four aspects, maybe it's 5 right now, 5 aspects that I'm going to predict are new. We're going to be new to your teachers. I think they're also new to you. And that is the use of setting a context by having a rich driving question, setting a context by having people experience the phenomena, and then based upon that experience, actually generating and asking their own questions, which in itself is a scientific practice, right? The idea of generating questions is a very important scientific practice. The idea of gauging kids in constructing models where they actually can explain why a phenomenon occurs is another important aspect, when they're building their models, they're going to take part in discourse, dialogue, talking to each other, which is another critical aspect about developing knowledge, and then constructing explanations, using appropriate and sufficient evidence. Again, another critical scientific practice where people don't typically have experience. And of course, when you're constructing explanations, as we try to model in some of the previous sessions, kids are they're going to work together to construct their models. They're once again involved in dialogue, but they're also going to share and critique their explanations. Another critical aspect. So you have to put teachers involved in each one of those situations when you're planning your own professional learning to really support them in what's going on. Now, the fourth, so those are some things that I always look at when I walk into professional learning, right? What do I have to help the teachers understand? And from talking with you and from interacting with you and from traveling to various countries, I know that those 6 ideas, I can list them if you want, or someone can type them and put them in the chat box. Those are going to be all new to you and your teachers. And so you're going to have to work in creating professional learning situations that can really help them. It doesn't matter if we're in the interactions curriculum, if we're in the health in our hands curriculum, or if we're in the water quality unit. Those ideas, understanding the driving question, engaging with phenomena and asking questions, taking part in building models to explain phenomena with others so we're engaged in dialogue, and constructing evidence-based explanations. We have to focus on helping the teachers understand those ideas. Because if we don't work at them understanding what a model is, they're not going to be able to construct a model in their own classrooms. They're not going to be able to support their teachers in constructing a model. It's critical. Now, so I have those general things in my head. I know I'm going to have to do that. When I look at the interactions curriculum, I say to myself, the same aspects. What do they have to know? And those ideas, experience phenomena, raise questions, investigate, develop models and explanations, they're there in the interactions curriculum. But when I also look at the interactions curriculum, I say to myself, there's some really different stuff happening here. And what is that's different? It's different in how we conceptualize energy. Energy, I'm going to skip a couple of slides. So energy, I'll come back to those. Energy is a really critical idea in our world, and yet it's one of the most misunderstood ideas that we have out there. Part of the reason is because people always want to talk about different forms of energy. There really isn't there's only two, basically all energy can be explained by kinetic and potential energy, right? You can also throw in electromagnetic energy. But bottom line is kinetic and potential energy and electromagnetic energy are the three aspects. Everything else, they're just manifestations of either kinetic, potential, or electromagnetic. And yet as a field, we want to, talk about chemical bond energy. We want to talk about sound energy. We want to talk about mechanical energy. And it just sort of confuses kids. And the reason why is there just becomes too many terms when really we want them to understand that when you see something in motion, it has energy, and that energy can transfer. At times, something has energy due to its relative position. And because of that relative position, it can have energy. So for instance, a ball on top of a hill has energy related to its position related to some 0 point, the ground, right? We call that potential energy. It doesn't mean that it has the potential to have energy. It says that that stone, because its position between where it's at and some 0 point, it has energy, and it can transfer that potential energy to a form of kinetic energy. So when I let the ball roll down the hill, that potential energy is then transferred over to kinetic energy. Now, often, as we know, the ball will stop rolling eventually, unless we're on well, in all our experiences, the ball will stop rolling. But in fact, if it was on a totally frictionless place, if I was at one higher point and I dropped something, it would just keep going and going and going and going and going, right? So kinetic and potential energy are two critical ideas. But then we bring in ideas like thermal energy, which is actually really an important idea, because when we talk about in our world, and we talk about efficiency of various apparatuses, often the thing stops working, right? Our whole goal in life, in our world, is say, can we just use a little bit of energy and have something keep going forever, right? This can't be. Why? Because there's always some energy transferred due to some kind of frictional force acting against it, right? So this is why cars, we constantly put, we constantly have to use energy in driving a car, but the potential, but if we keep doing it. Why? Because there's a counteracting force against the force wanting to go forward. And so we lose that energy to basically random motion of molecules. Now that's a kinetic energy, right? Why does the car stop rolling? Well, because it creates random motion of other molecules, air molecules, the molecules on the ground. That's often causes a temperature to increase. And so we call that thermal energy. But in fact, all thermal energy can be explained in terms of kinetic energy. It's just tracking where the energy is going. So in the interactions unit, because we focus primarily on helping teachers understand and kids understand there's only two major forms of energy, kinetic and potential. And that's really a hard concept to explain to other teachers, because I was raised my whole entire life on ideas of chemical bond energy, sound energy, you name it, different kinds of energy. But we now know through research that that isn't the way, right? Modern conceptions of energy, current conception of energy, if you talk to a scientist, it's kinetic and potential energy and electromagnetic. I don't want to throw out electromagnetic, but in interactions, we're basically focusing on helping kids really explain all phenomena in terms of kinetic and potential energy. Now, we explain potential energy based upon understanding something in a field, right? So where's the energy when something has potential energy? It's in the field. When I talked about the ball on the top of the hill, that's a gravitational field. When I put two like charges together and they're very close to each other, we know if I have a positive charge and a positive charge, and I try to put those two positive charge objects together, we know that it's really hard to do that, right? So that when they're held together really closely, they have lots of potential energy. And if somehow I let them go, they'll fly apart, right? So that potential energy that's in that field, that electromagnetic, that field around those two positively charged objects, that potential energy that leaves that field and gets transferred into kinetic energy. So all phenomena can be explained primarily through the use of kinetic and potential energy. And that's what this unit is all about, right? That when we created this unit, that was the goal, was to help kids understand current conceptions of energy, because it's so critical as they move forward in more advanced not only in advanced studies, but in understanding the world, rather than memorizing 30 different types of energies, what really get people confused. We try to be very simple, not simple, it's explaining it at its mechanistic level, which is kinetic and potential energy. From a chemist standpoint, or I guess actually from a scientific standpoint, I've always I get upset when I look at various textbooks and I see when a chemical reaction occurs, right, and atoms break apart, energy is released. That is the most false aspect in the world, yet we see that all the time. So people think in order that when a chemical bond breaks, they think energy is released. And you can think back to your education. You can see those images in your mind. I see them all the time. That's a false idea. Chemical energy, when is energy released in a chemical reaction? Energy is released in a chemical reaction when a bond forms, not when a bond breaks. And that's why having all these various terms, mechanical energy, chemical energy, sound energy, can really get kids confused. So one of the things I really focus on when I'm doing PD with respect to the interactions curriculum is how can I get other teachers to understand this? Because that is such a challenging aspect, because otherwise they're going to want to say, well, I've always taught it these different forms. And the kids probably heard about these different forms in middle school. Yeah, that's because we're trying to change what happens in middle school too, or in high school, right? So we really have to work with our teachers to get this new vision of energy across to them. So I did all this last talking in the last 40 minutes or so with the vision of what do I do when I plan professional learning. I always say to myself, what's critical about this unit? I got some good curriculum materials, and you guys actually raised this yesterday too, where you said, I can't give my teachers these 130 pages of teacher materials that are written in English, because they're not all that good at reading English and they're never going to be able to read this. So I have to translate it into my own country's language. This is true, right? And we've actually tried to make those materials educative for teachers as well. So we put various supports in the materials so they can understand how to support teachers and how to support children in building models. How do you support students in writing evidence-based explanations? So we have all those supports in the curriculum, but if the teachers can't read the materials, then it's not going to be helpful. So we have to translate those. So I go into a professional learning situation saying to myself, what is it that the teachers really have to know? What can I get them to experience? Because I can't get them to experience the whole curriculum. I wish I could, but I can't. So because I don't have the time. So what do? I pick what are the most powerful lessons they have to learn, and I focus on that. And so if I was going to plan professional learning with interactions, one of the things that I have to focus on is helping them understand the different conceptions of this new conception of energy. Because if I don't help them understand why we're just focusing on kinetic and potential energy, and I'm trying to avoid using all these other phrases like sound energy, right? You can explain sound energy simply by the movement of molecules. That's what sound is. It's not something special. It's the organized movement of air particles. bumping against each other, right? And causing a wave to occur. So there's no reason to introduce new ideas. It's actually helping them understand at a mechanistic level what's happening. And unless we do that, then the teachers will not be successful in the interactions unit. So I'm going to stop again and see if there's any questions. So, I would typically when I do this, I would not just bring up these ideas. I would actually have you experience these ideas. It's a little hard being across the ocean and a 12 to 13 hour time zone difference away, right? So, but I'm bringing this up. I brought this slide up just to show you how I like to, what is it that we're focusing on, right? So we're focusing on kinetic energy, which is basically the motion. It's motion energy. It's due to the motion of objects, and of course, it's proportional to their mass, and it changes with their speed. And of course, it's its velocity because it grows with the square of the speed. Thermal energy, which is a subset of kinetic energy, is very important, as I mentioned before, but it's not any systematic, right? So if I get all particles moving in one direction, right? If I get air molecules moving in one direction, I get a sound, right? Because of their bumping nature against each other. I get noise when there's this random collection. So thermal energy is, in many respects, is just a random motion of particles in all various directions that occur by collisions, right? So when I get a car rolling across the surface, is basically going to lose energy because it's going to cause the particles in its tires and the particles in the ground to heat up because they're moving different and faster. It's also going to knock air particles out of the way, which is going to cause a transfer of energy. And then there's potential energy. And getting kids to understand potential energy is going to be challenging because, as I mentioned before, that's just really energy stored in a field. And so getting kids to really understand that idea is really critical, right? So I talked about this idea that basically you get potential energy because it has to do with where something is in comparison with something else. So we talk about, understanding gravitational energy is probably the easiest, right? There's the field between where the object is and some arbitrary bottom point. And when that, based on that position, when the position changes, that potential energy is converted to kinetic energy. And of course, one of the other big ideas behind energy is really helping them understand conservation. So energy is never lost. It's always here, but it gets moved around. And unfortunately, we haven't figured out how to really maximize our capturing of energy, right? That's always been our challenge, is to try to make things more efficient, right? When we talk about the efficiencies of motors, we are basically talking about how can we get them to run smoother so that I can capture more of that energy. I have to put less energy in and get the same amount out, which would really help us. So just to show you, don't read this. Anyways, so this is one of to show you the challenge. And this is actually a fairly sophisticated question. The question here is, you have these two carts, and underneath these carts are these wheels. Everybody can, right? There's these little wedges that are holding this cart back. And the reason why it's holding this cart back is because this sheet is negatively charged and this sheet is negatively charged. And the question we ask the kids is, what would happen? Predict what happens if I remove these wedges? What will the car do and why? That's a very sophisticated question. But if we can get kids to answer, understand this question and explain it, they have just a ton of load of knowledge in their heads that they can use to be able to explain other phenomena. Now you could ask, Joe, where is this really true in the real world? That's a good question, but it's such an important question because this is an example of electrical charges. And we know that when electrical charges, just like if we put two magnetic charges, right? You can almost, if you want to begin to think about this having two magnets with the negative poles facing each other. If I remove those wedges, right now they're in a strong potential energy field. Their potential energy is pretty strong, right? If I keep trying to push these things closer, it gets harder and harder and harder. The potential energy increases greatly. If I release those wedges, then we see an acceleration back. And that's because they were in this potential energy field, and that potential energy is then changed to kinetic energy. So it's a challenging question. And of course, it really gets challenging because part of responding to this question is having them understand, why does it stop? It's not only why it starts, it's why it stops. And the reason why it stops is because if it was a totally frictionless plane, it wouldn't stop. But it's not on a perfectly frictionless plane. There's friction around, right? There's the air particles, those parts that are up in the air, they're acting as sails that will help us slow down. And there's also some connections between the wheels and the table that will slow it down. And so that potential energy is transferred to kinetic energy. And while it starts off very slow, the potential energy decreases and the cart slows down. Why? Because some of that energy is transferred to thermal energy in the environment. So it's a very challenging question, and it eventually will stop. I see a comment in the question from Darren. I always pay more attention when I explain potential energy because it's easier to explain potential differences in electric fields comparing with height differences. Yeah, if you can set up these kind of situations, it is really nice, right? I actually don't mind playing with magnets. I do it more at the middle school level, but helping kids understand fields with magnets at the middle school level, I think is really, they have a lot of experience with magnets, so you can show it real easy. Setting up in the middle school electrical interactions like this is a little bit more challenging. We can do it, but it's a little bit more challenging. So what you will see in this curriculum is we slowly try to build those ideas related to energy transfers. This is a particularly fun demonstration. I don't know how many of you have ever seen this, but it's really wonderful. It's a macroscopic explanation of a variety of the ideas we just talked about, but also really trying to help showing the kids the understanding that kinetic energy is a combination of both mass and velocity. And I'll just ask you this question. I apologize. I should have put the link here to the video. I'll go find the video in a second. If I drop this ball, so the situation here is I have a basketball and I have a tennis ball, and I'm going to drop you know, if I take the basketball and I take the tennis ball and I drop them, they're going to hit the ground, and they're basically, you know, they're not going to, neither one of them is going to come up to the same height. Why? Because it's not perfectly inelastic. It's not a perfect collision. Why isn't it a perfect collision? Once again, because some of that, the potential energy was changed to kinetic energy, but some of that kinetic energy is lost to the environment in the bounce, right? The thing bounces and you get some, it causes the molecules, when it hits the other surface, it causes both the molecules in the object itself to vibrate a little bit faster. It also causes the material that the floor is made out of to move a little bit faster. So there's always a loss of some of the energy. And so the ball doesn't bounce back as high as it was before. There's always this transfer out of the system. So in this case, if I drop the two balls, they're not going to come up to the same height. They'll come up somewhere close to it, right? And unless I have perfectly elastical surfaces, and I don't have those, but you know, you could have those. So then the question becomes, what happens when I take this small tennis ball and I put it on top of the basketball and I drop it simultaneously? What happens? What happens to the big ball? What happens to the basketball? What happens to the tennis ball? Now, if you've seen this one done, it's quite fascinating, actually. Any predictions? Anybody will put a prediction of what happens to the tennis ball?
When it falls?
Prediction?
When they falls?
What happens when you put the tennis ball and the basketball and they drop together? What happens?
It jumps higher.
Jumps higher? Why does it jump higher?
Some people look to the and ask.
Go ahead. I was just trying to find the video. Why does it jump higher?
So they falls together, and when a basketball ball touches the ground, tennis ball will continue to move downward. So, and how to say, in the moment when basketball ball touch the ground, it's a little bit, it has, how to say, collision. And when basketball will jump, it can help tennis ball jump higher. It's something like gives him more energy.
Right. So there's a transfer of energy, right? There's a transfer of kinetic energy from the basketball, right? So the balls are dropping simultaneously. There's a transfer of kinetic energy from the big basketball to the little tennis ball. But the basketball is much more massive than a little tiny tennis ball. So when that transfer occurs, that tennis ball shoots high up in the air. Now I'm going to stop sharing my screen, and I'm going to go share my screen again because I found an example of it. I think hopefully everybody can see this. I still have to play it through a little introduction here, but let's just watch this.
Our job is that
Hello, I'm Bert Yang, and today I want to show you a simple demonstration that I like to use when we start our investigation of momentum. Now, it begins with a basketball and a tennis ball, but we're going to try it with some other materials also. So let's go get started. Come on. Now, this demonstration is going to start with the idea that if I drop a basketball and tennis ball, they will both fall and accelerate towards the ground, 9.8 meters per second squared. And if I drop them, well, you see that they both fall and reach the ground at the same time. Now, instead of jumping them side by side, what about if I put the tennis ball on top of the basketball and release? Well, let's see what happens.
You also notice, by the way, that the tennis ball, they didn't come back to the same height. Neither the tennis ball nor the basketball came back up to the same height. Why? Because there was that transfer of energy to the surroundings.
And see what happens.
This is a cool one too. What's going to happen now to the big basketball, right? What's going to happen to the tennis ball? So this is the opposite of what I said, but we'll keep playing this for a second.
1, 2, 3. How about we just drop the tennis ball on top of the basketball and see what happens? Well, that's disappointing. So what is going on here? Well, let's track the height of the basketball when it bounces by itself versus when the ball's on top. Okay, so we'll drop it at your head. Right? So about there. Let's try that again. Right there. All right.
Again, there's a loss of some energy, right? That's why it doesn't come back all the way up to his head.
Good. We have it down there. Now let's try this with the ball on top. Yes. The difference in the bounces is said to be the momentum transferring from the bed.
I'm gonna just play that over again. I'm surprised they didn't do it again, but
Yeah. All right, good. We have it down there. Now let's try this with the ball on top.
watch what happens to the ball.
The difference in the bounces is said to be the momentum transferring from the basketball into the tennis ball. And ideally, this is said to be able to go about 9 times higher than what this does. When we set about testing it, our results weren't nearly that good. The best we could come up with is about 6 times higher than the height of the basketball. The tennis ball has less mass than.
So theoretically, it should go back 9 times. The reason why is, again, because there's a loss. It's never a perfectly elastical collision. If it was a perfectly elastical collision, you would, but you don't. You notice he introduced the idea of momentum. There's nothing wrong with the term of momentum. I always like to avoid, eventually I'll talk about momentum because it is an important physics concept. But I'd like to first have kids understand things by fundamental concepts. Because if you can, this is one of my basic principles that I always do. And because this is how I can explain the world. If I really have some understanding of some fundamental concepts like energy transfer, because that's what's happening. That's what's happening in this ball demonstration. You're getting a transfer of energy. That's why you can use that idea to just explain numerous phenomena. So there's a transfer of energy from the basketball to the tennis ball. The tennis ball goes so much higher because that basketball had so much more kinetic energy than the ball because they were falling at the same speed. But the basketball is so much more massive than the tennis ball that you get this, the tennis ball just flies much higher than the basketball. It really is a wonderful, fun demonstration. Now, I do all this to say, when I gotta reshare my screen again. Not sure what I shared. So I think you can see this pretty well. The reason I brought this up is, to me, this is like if people can explain this, this is a critical idea. And so this would be one of the experiences I would actually do in the professional learning. I would actually do the bouncing of the basketball, and I would try to get them to understand it. Now, we also know in the interactions curriculum, as in the other one, that just having one experience isn't enough. So we have this experience tied to the kids using a simulation. where they can actually see the change in what happens when two things collide. So they can watch the differences in the kinetic energy and the potential energy and the total kinetic energy. So that it's this is what we try to do, or the kinetic energy, the right object, and the kinetic energy, the right object in this case. So we like to show them how this stuff changes. And you'll notice on this particular simulation, you can also change the mass. So what's the difference in kinetic energy? In this case, these are going to be elastic collisions. So in elastic collisions, you don't have a loss of energy. So when mass is the same on both these objects, but one starts off faster, one starts off slower, and they collide, what happens? You can say they're both the same mass and the same speed and same mass, what happens when they collide? And you can see with their changes in kinetic energy when they collide in this perfectly elastical collision. And so we try to have them use both real world experiences as well as simulations to try and understand. And of course, these simulations, like the curriculum, are open source, so you can use them as part of your work. Now I'm going to stop because I'm over my hour, but I wanted to give you a feel for how I go about doing professional learning, which is really trying to focus on the important ideas within the unit. So I'm going to stop there and see if there's any question, and then I'm going to pass this on to Buren or Kessera and see. I can either continue or we can. I think someone was going to present their professional development plans today. So are there any questions? I love that demonstration, and actually you have to do it, if you have a basketball and a tennis ball, you should go home and do it. But in fact, you can do it with any two objects or any two balls. So if you have a tennis ball and a ping pong ball, you can do it with a tennis ball and a ping pong ball. You want to be a little careful. I once did this, and it's not a good idea. Why? Don't put a BB, like a metal BB, on top of the basketball. Because the BB also doesn't have very much mass. It doesn't have as much mass as the tennis ball, but it's metal. And it will fly off extremely fast. It could hit someone in the face and really hurt them. So don't do it. It really flies off. Or sometimes you got to be really careful about what's above you, because I've actually in the past hit light and broke a light with a tennis ball. So you want to be really careful of your environment, but it's really fun to try these. I would say go home, have a little fun with science yourself. Take a ball, drop it, take two balls and one on top of the other and drop it. It's really quite fun. And then try to explain it in terms of the transfer of energies, right? That's what science is all about. You want to experience phenomena, and you always say to yourself, why does this happen? How can I explain it? Oh, what is a BB? Sorry. A BB is like a really small round ball, but it's made out of metal, right? So it's like trying to think of what's another name for a BB. Anyway, it's a small round metal ball. And ball bearing, good. Yeah, that's the full name of it. A BB is a ball bearing. So you take you can do that. Well, so you can use a ping pong ball, right? And it's fun. You can say to yourself, what about if I use a ping pong ball versus a tennis ball? What happens? Will the ping pong ball go higher? Will it go lower? What happens if I drop the ping pong ball on top of the tennis ball? What happens, right? So those are different kind of materials. You could use a metal marble is like a BB. You also want to be careful with a marble as well, because marbles can also hurt. So if you use a marble, right? I mean, a marble is a small object, and if it hits in your eye at a very fast velocity, you're going to lose your eye. So if you use a marble, you make sure you and anybody else around you standing back. Everybody else, if you're doing a marble, make sure you stand back. And you have to make sure that you have a set of protective goggles on. But the fun thing about the marble is the marble will shoot very high, a glass marble. You have to make sure what's above you, because if there's a light above you where you drop it, you will blow out that light. So you want to be very careful. But I would say go home, try a variety of different kinds of balls. You can certainly try a marble, but again, I would wear goggles and I would make sure, if you're in your house, the ceilings in our houses aren't as high as the ceilings in school. So you want to make sure that there's nothing above that you're going to break. I've actually broken stuff already, so just be a little careful. You can try a golf ball. Peter says even a golf ball is dangerous. Yeah, because it has a lot of mass, right? It's small and has a lot of mass. So, if you're cautious, you're okay. Sometimes it's fun just to try these things outside because, there's nothing above you. But what you really want to make sure is that if you have like a marble or a ball bearing or even a golf ball, that there's not other people that are very close, because if it flies off at an angle, and sometimes it can do that based upon how you drop it, right? So if you don't drop it, if you don't have that other ball, the top ball exactly in the middle of the big ball, it will fly off in a different direction, right? If it's on the side, it'll go off in that direction. And it'll go off in that direction in a very fast speed. So you want to make sure that you practice, right? You always practice, right? You want to do it by yourself. I guarantee you, the first time you do this, you will not have it exactly right. So practice and play and be safe. Otherwise, it's fun, and it's really then fun to say, okay, let's explain this then in terms of the transfers of energies. What's going on, right? So they have the same gravitational energy. They're falling. Gravitational energy is being transformed in kinetic energy. It hits the ground. We get an imperfect collision, so some is being lost, the thermal energy, but there's then going to be a transfer back up going against gravitation, but it's then going to hit the other ball, and because of the differences in masses, one's going to fly off much farther than the other. So it's a really nice kind of explanation to try to get into. So I'm going to stop there, and I can continue to keep going, or I can ask, or I can see if Buren wants to go on with the other parts.
Yeah, thank you, Professor Chu. I think Dr.
Yeah.
Kessler will join us soon. She's in another session. So basically what she would like us to maybe discuss is the plan for the next consultation. As you suggest that how we make this consultation is more effective and also more benefit to people when they want to do their PD. So one way that Dr. Kessler would like maybe some of us that can share their experience when they do their PD, or also the plan, what they have in mind, that when you want to do the PD, for example, do you plan to do like the online or on-site? Yeah, something like that. And what about your target audience? Do you plan to do the PD for the teacher or for the P-service teacher or something like that? That what Dr. Kesala would like us to look at all these aspects, and also maybe share some experience with each other. And I learned from Dr. Kesala that some of our colleagues from Thailand also have some experience on the PD, and maybe would like to share with us a little bit, right?
Right. So I thought, Buren, what I would do is I'm going to share my screen again. And this is the last slide that's on the PowerPoint. Shoot, it's my slide. Hold on, I'll go do it the other way. I'm going to make a slide And I think we'll put that stuff down on a slide about what everybody should come with to the next professional development session. How's that? I think that would be a real
Yeah.
valuable. I think that will be valuable for everybody to have.
In the basketball, the transferred momentum will.
So if everybody, so I'm gonna go into our slides. Again, the slides are on the slides are on the. Oh, how do I do this? I'll tell you what, I'm just gonna send this slide to Buren. It'll be easier. I'm a little bit, I'm just gonna work on my slide. You can copy these notes down on your own, but then I'll send this slide to Buren as well, and then he can share it with you. I think right now that'll be easier. So so I think we should write down these requirements. So for your professional development plan, the first thing I heard Buren said is context. Online or face-to-face sessions, right? That was the first thing Buren said. Buren, what was the second part you said? I sort of lost track.
Yeah, the target group, whether it would be the teacher,
Target group.
yeah, or the pre-service teacher.
Of course, we want to know what curriculum it is. But it should focus on what the next one is, right? So the next session that we have will be coming up in a couple of weeks. And that session I don't recall. I have to get to my Thailand slides. Do you remember what here it is, Thailand work. So I believe the next session will happen on January 23rd, and it's going to be health in our hands. So
Yeah, that's also that we maybe would like to discuss as well, whether that's the time that we plan in the schedule that we sent previously, is that appropriate? Or because some people would like some time to work on their PD. I'm not sure that they all have the plan for their PD and ready for the consultation or not. Maybe some of them need maybe more time to plan on that, and then later on they maybe have something that would like to discuss with you that maybe could be the most useful. Other than that, we keep going, and then people have no idea what they want to do or something like that, or they don't have any question or any concern, because we think that we maybe should give them some time a little bit, and then when they settle down what we have, their plan, what their logic framework, and then maybe they have something that they would like to seek your advice or suggestion, and maybe also share the experience with other colleagues as well. So what do you think? And actually, I would like everyone to share their experience as well, and also their comment. That would be really welcome, so we can plan our PD session efficiently.
So I think I heard you say, and I could be wrong. You at the next PD session, you would like them a little bit of time to plan? Or would you like them to come with the plans?
We would like them to come with the plan.
Right, so somewhere between now and January 23rd, because we have 2 weeks off. You
Yeah.
should come with a plan. With,
Right.
and the plan should consist. Is it gonna be online or face-to-face session? What's your target group? Are we gonna just focus on health in our hands, or could it be any three of them, Buren?
Any three of them. I think it could be any three of them. Previously, what we did is we divide into the for each unit. So because people not working on all the three units, so maybe some people work on the water quality and other work on the health in our hand, so they can choose which one that they want to participate, because otherwise if they attend every session, maybe it's too much for them. That's why we devise it. And for now, we maybe would like to seek their SY as well of what we if they want to stick with the same that we separate in for the three unit separately, or they would mix, they come together as a one consultation session. Is depend on who come to attend at that time, and maybe they would like to discuss on the interaction, maybe would like to discuss on the water quality. I would like them to share their idea. What the most efficient day for them.
They might have related to each one of the plans. Is that correct?
Oh, sorry, I lost the connection.
Oh, yeah, I saw that. So I'm just trying to repeat what you said. I think right now you would like to get the opinions from the participants on how they would like to eat at the next session. So
Right.
do you want them to speak out? So
Yeah,
what
please.
people should speak out like to proceed at the next session?
Yeah.
Any comments for anybody?
Just to give you some information about what we are doing at Jula in Thailand, and Ajahn Pachari is here. She can help me add more information if you like, Pachari. For Jula, Ajahn Pachari and I've been talking about our professional development program, and Pachari is writing proposal of how we are going to do it. So if you like us to share a little bit what we are thinking about tonight, we can do a little. But if you would like to us to come back, we can maybe send you somewhat what we planned before 23, and then we can meet up on 23 to discuss in details. Patri, do you think this is a good way to do this?
Yes.
Yeah.
So if Professor Joe would like to see our plan, so if you have any suggestion, so you can do it, and then we can go back and then talk to our colleague and revise our PD plan, and then we can show you again next time.
I think that's a good idea. I think you could still see my screen. So I'm writing in to send professional development plans to me.
Yes, and I can show right now here to
4
get
days
some
next-
feedback.
I'm sorry, I interrupted you. Keep going.
Oh, no, I mean that I can share tonight, and then we can get some feedback from you. So if you want to,
Yes, I think that's a good idea. So you're gonna send me your professional development plans to Professor Joe, to me,
yeah.
and Joe will,
It is
Joe
not
will,
it is not completely finished, so I can share
Okay.
my screen and then
S-
present what we have talked about our PD plan
how about this?
for
Send draft professional development plans.
yes. So if you stop share and then I can share my screen and then we can go back to your
Okay, so,
slide and then we can talk
yeah, I
to
like
each
this. Yes, so I'll stop sharing and you can share. There was someone that had their hands up, so I want to make sure I respond to them first. But I like this idea that everybody should send their plans to me, and then I can critique them, and then you can share them to the group. I think that's a really nice idea. So if people can send their professional development plans to me, again, draft, I realize it's a draft. Which means just beginning draft. We'll say draft beginning professional development plans. So I understand it's something that's just beginning. And then I can comment on it, and then you can modify it, and then you can send it back, and then you can present it to the whole group. How does that sound? So so someone did have their hand raised. I don't know if they still have it raised.
Yeah,
But
and from Cambodia, I do support for the ideas of Pachari want to share some the draft of the professional plan. So that is the good ideas that we can see and have an idea to begin the draft. Yeah, thank you.
So do we want to go ahead and then have the people from Thailand right now just share their plans? That's what I heard we said we wanted to do. Should we do that?
Okay, can you see my screen?
Yes, we can.
Yes, it is not finished yet because I am still working on it. So as we know from Dr. Gesara that we will receive the grant for 300,000 here, and then we're trying to plan to reach the research objective for this professional development. So we have 3 of these research objective. The first one is to investigate the implementation of Michigan State University. The second is we pay attention to the teacher perception on scientific explanation, or CER. And the third one is to back to the context of the Thai teacher. When we talk about the model, they will usually understand in terms of the concrete model, but not just for the something that we can create by like a sage modeler that we have done. So, and then the scope of the study is the target group of our PD is the science teacher who teach the lower secondary level for total of 30 individuals. Okay, and then this is we have talked about the criterion for the application. So we thought that we might announce for the teacher who willing to be at a part of this professional development. So after we announce the criterion for the application, and then we let them send their resume for us, and then we will choose based on our criterion. So we hope that they have at least a 5 year of teaching, and this is for the grade sentence. I'm not sure. So I just it is might be good if you can share your thought that is it necessary for the applicant teachers to have certain teaching experience before they apply for this PD program. And then we plan for the whole year, and then we can end at the December 2024 this year. So for our plan, as we first, so we will talk about we will set the vision and the goal for the science teacher professional development. So as you say that what is new for the science teacher, and then what is new for our as a professional developer as well. So we can talk about this, and then we can talk about the goal of the CMO STEM that provide this grant for us, and what is our role as a professional development. And then we can compare the point of the US NGSS curriculum, because I know that you are based on the competency-based curriculum, but for in Thailand right now, we are based on the standard-based curriculum. So we focus on the learning indicator, but sometimes we have to mix it to be reached as standards, as the same standard as NGSS does. And then when we look inside NGSS, so you will have a cross-cutting concept. You will have the SE, so I don't remember the triangle and the part of the NGSS, but it is quite different from the curriculum in Thailand. So we have to see what is the point that we can match each other right now. And then we will, so when we will look through the activities and then translate to the Thai language, because it is some activity is too much, so we have to go back and talk and then choose what is proper for the Thai teacher and the Thai context. So this is the second part. And then for the third is a big one, is like this. So this one, so we plan to blended professional development with the on-site workshop. So we will do 3 times for two days for each time. The first one we are dedicated to the water quality, and the second time is the interaction, and the third time is the health in our hand. And then we will let the teacher implement the activity in their school context, and then we will do the online follow up for 3 times. So we will let this time is about two or 3 months for this. And then at the end, so we as a professional learning community, so we will see each other again, and then reflect. So what the teacher changed, and then what the teacher had learned from this unit, and then we can look back and revise whether or not we have a PD plan to make the teacher change, or our PD is a benefit for the Thai teacher. Okay. So yeah,
I think you're off to a very nice start. That'd be my comment. I think for related to
Yeah.
your that you had, I think that's more of a question
okay.
related to stuff to do. Keep going.
Yep. For this one, so I looked through the lesson for the water quality. It has 11 lesson, but I have to go back and then and talk to my team, and then can select. So how should we make it fit for today here? And then it is not finished yet, because I have to go back and talk to our team. And the same as the interaction. So when so they have a 4 unit, but we can implement just the unit 1 because it is a very too much, and then when we look in detail is composed of 800 pages for the unit 1 is too much for us, and then again, so I have to talk to my team which one that is a part of the activity, and then we will look back to see your video again that you summarize. So what is the point of this interaction, and then we can plan to fit for today. And again is the third activity, health in our hand. So we will do like the first 2 activities. So this is the plan for Chulalongkorn University that we plan for the PD for our teacher. So again, do you have any comments or any suggestion, Professor?
You know, I think you're off to a really nice start. I really like having your timelines. I put that in the slide I was making so I can send it to Buren. I like the idea of having this timeline, and I really like the idea also. I really how you started off specifying what your goals are. I think that that's really critical. So knowing what the goals are that you want to accomplish in the professional development session, I think is really critical. And I think you started off that way. And I really like how you progressed to having this timeline. I do have one question. I don't understand on this slide, when you say there's 2 months for 3 activities, does that
Yeah.
teachers will implement 3 activities, or that's what I don't understand what you mean there.
So for this one, after we teach our teacher for 3 activities, and then we let them choose. So which what activity they are willing to implement in their schools. So they can choose 1 or 2 or up to 3. So it's up to them. But we will leave the duration here is just for 2 months.
But if they just do an activity, what's an activity? Like a lesson?
Yes.
So if they just pull one activity out of the unit, the kids aren't going to really be able to experience the full benefit of the unit, right? So because the units build across time. So that's why I'm a little confused about just implementing 3 activities, right? Because even if you look at something like the water unit, it starts off by the kids experiencing, going to the stream, and then learning the various water quality tests, and then constructing an explanation. So it's hard to just do 3 activities. You really have to start with the driving question and then build from that. So one activity for all the groups would always have to be the driving, experiencing the phenomena and the driving question.
Okay, yeah. So I will go back and then talk to my team, and then we can revise maybe so they can choose just 1 because of the time. Okay, thank you.
Even if they just do 3 lessons or 3 activities, they're really not going to experience the materials. But again, this is up to you and the program. I'm just saying that from my perspective, if we really want to see the benefit of this, then it has to be, they have to do a they can certainly implement it, they can certainly modify the materials to fit their environment better, but they have to implement the entire thing. Otherwise, just doing 3 isolated lessons, we're really not going to see anything.
Okay.
At least that's my, that's my professional opinion.
Yeah, it's makes sense as well, because as I plan, I just think too much. So how much time do I need? So when you provide your suggestion like this, it's
Right. Even
it's
for
very
instance,
good.
right, if you think about if you think about them developing an explanation, right? Even an explanation is probably going to be at least 2 days, because one day you have to ask the question, they have to experience the phenomena, they have to analyze the data, they have to collect the data, they have to analyze the data, and then they have to write the explanation and share the explanation. That's at least 2 days. Now, maybe that's okay, but that, again, that's up to Kesara. But yeah, they're not gonna, they're only gonna do a very small part of the unit. But maybe that's, again, but it does take time to do some of this. Like, if you want the kids to design a model, they're gonna have to learn the ideas, they're gonna have to have experiences related to what they're modeling. Then they have to construct the model, they have to share their models, they have to revise their model. It's gonna take more than just 3 days, so.
Okay.
Yeah, I think that I like to throw back the ownership to the universities, like that. If you really think that this unit is worthwhile, right? And how do you embed this unit lessons in the in your course, right? And it might not be able to finish in the first year, second. I think that if you already learn that this unit is great, right, within the existing structure that you got, how are you going to manage it? And at the end of the day, you also want to learn, right, that if the teaching students are able to apply them effectively, right, but under the condition that they must be able to get the right input. The right input is the training, and also be able to implement them so that they can see the result from students. But the dosage is very important, always very important, that how much we train them and how much time that they are able to expose students to these learning activities so that they can see the result, right? Yeah.
So for Professor Joe, I have another question that for me and Dr. Parinda, we have talked that we will invite, we will select the 2 teachers from the same school. So when we do the professional learning community, so they can be a partner to observe when they teach, and then they can help each other and reflect. And then when they online with us, they will have like a key message or any other guiding.
Yeah, so
by
the key idea of this idea is because in Thai context, we had a research found that when teacher been training in any professional development program, if they go back to their school and they have to work on their own, they're tending not to change because they feel uncomfortable to move the change by themselves. So Pachauri and I thinking about using the lesson study by having participants working in pair from a school so that they come in learning with us, and then when they go back, they have partners to help reflecting each other and making a move together. Do you think
Yeah,
that's okay?
I think that's a great idea. Aspects related to lesson study where, they watch you talk about what you do, and then they have partners at their own school where they can go watch each other and share ideas. I think that's really critical.
Okay, thank you.
Okay, I will stop sharing. So any
Yeah,
other suggestion?
Right, so you can send me the questions you have, and I can respond to them, and if you send me your professional development plans, I can give you more comments on them.
Okay, thank you very much. Okay.
But it's a very good start. Kessler, I don't know if you have any other comments? You're muted.
Yeah, my apology that I just finished attending another webinar. So I think I will maybe discuss with you, right? But I think as we discussed at the beginning, that I think every change, right, needs a little bit of management, change management, that how you're going to start to maybe change a little bit of the adjust your structure, the teaching scheduling. Overcome, or maybe try to have the implementation level that quite that can fully benefit to your teaching students, or the teachers. And I think this need this need more work, that you might want to work among the faculty member and see maybe multiple teachers work together, the multiple faculty member work together, that how they can adopt this unit together. And likewise, maybe multiple teachers who teach the subject that related to the learning units can see that how they can work together and adopt these learning units. And because I think that we want to see some change, and the change start with the implementation level that is quite extensive enough, so that you can see the change within the time frame that you don't have a lot. Yeah.
So I think I saw a hand go on, but it disappeared. So I don't know who had their hand up. So someone raised their hand.
Yeah. For example, I share with you that we just implement the pictures book in the program of Chevron Enjoyed Science, and we introduce the technique of the how teacher introduce a picture book to their classroom, right? But the technique, they have to repeat 3 techniques. One technique for one day, using one book will use 3 techniques, and the second book in the second week, they do this for 10 weeks consecutively in order that we can see some result, that teachers and students get used to those techniques, right? So I believe that if together, if we can help you in any way in communicate with the teachers, with the principals about the benefits, and as I always mention, that if you can recruit teachers who are passionate to adopt this, and they will try to work around, and we also can help communicate with the principals, that how this program can help teachers improve their practices, right? And so that they can be maybe the teacher leaders in the future. Yeah, I think that is our goal. Yeah, we would like to see that if teacher adopt, teacher implement, we can see change, that we can collect data. We mean us together, the researcher who are going to be nominated for this program will collect data. If the dosage is too small, too thin, we will not be able to see much result in the research. Yeah. And yeah, I know that this needs helpful. Until we have that clear logical framework that what we are going to do, I think it will be the right time to move to the next step of consultation. That's my idea. Yeah.
Okay, so we'll move forward. Kessera, I think maybe you and I should meet next time because I'm not. I don't know if you want if Consuelo is needed there next time or if Anne is needed there next time or if I just need to be there next time. So we should if
I think we discuss first. Yeah. Yeah.
anyways, everybody, once again I have to go. I did put the PowerPoint that I created with sort of like some ideas of what you would include in your professional development plan. I thought we saw a good example of the beginning of a good plan of a professional development. And I do like that idea that if you send it to me, I can certainly provide you with some feedback, right? Don't send it to me the day before. Before to look at it, right? Send it to me at least a couple of days ahead of time, and I can then look at it and provide you some feedback.
So when we because Dr. Burin, when we meet next, did we schedule yet, or we will communicate with them later? How about that?
Yeah, I think our next meeting is January 23rd.
Yeah, that's the
maybe-
schedule.
Yeah.
That's according to schedule, right? Yeah. So how about this? Let us get back to you again to see that how settled about the logical framework that each country need to submit to us. I think if we have that clear, I think it will help the plan to be aligned with the project plan in each country. How about that? Right, and then we will Dr. Burin will get back to you about when will be the next session, so that the session will be quite in alignment with the country plan. Yeah. So Joe, you need to run, right? Yeah.
Right. I'm responding to a question. So
Okay. Yeah. Bye.
really email the plans to me, or you can put them in the Google Doc and then email me and tell me it's in the Google Doc, in the Google folder. So there's a couple ways you can do it. One, just email it to me. Two would be to put the plans in the Google Doc, in the Google folder. Now, the advantage of putting it in the Google folder is everybody can see it and I can write comments on it. And it's there. But if you do that, which is a good idea, maybe each country could have their own folder and you can put your professional development plans in there. You can email me and say, Joe, our plans are up there. I can go and make some comments and then you can respond. But once you put it in there, you have to tell me it's in there. Otherwise, I won't know it's in there. Right? So I'm not going to go every day and look to see who's there. So I like the idea of each country having a folder. You could put your professional plans in there. You email me and say, hey, Joe, go look at our document. Or if you have comments or questions, you can put them on the email and then I can go look at them. I can, give me a couple of days to respond and then we're great. I have to go. I'm late for another meeting. I'm really sorry.
All right.
Well,
Bye. Bye, Joe.
Thank you. Bye-bye.
Yeah, thank you. See you next time. Okay. Yeah. So yeah, I think we will get back to you about the next schedule and we will try to organize a meeting with the team, with the PD team and the project team, so that the project team will try to synchronize about the training plan. Okay. And Dr. Burin will get back to you on this arrangement, both the meeting and the next session with Professor Joe, right?
Yeah.
And do you have anything else to announce, Dr. Burin?
No, nothing.
Nothing. Okay.
Yeah.
Yeah, I apologize that I didn't come earlier, but I appreciate your time, and I look forward to next meetings. Yeah, and have a good night.
Yes. Before we close the meeting, so I have a question.
Yes, please.
What shall we do next week?
We will reschedule the meetings, and to the time, I think we will let you know again. I think that it should be maybe early February. Dr. Burin, do you think so? Around we will reschedule very soon, so that we prepare some time for the team to finalize the PD plan together with the project team, like in other countries, like in Indonesia. We will set up the meeting so that you can finalize the plan with the Dr. Wayudi of Simulec for Kazakhstan with Caravan of Knowledge, because the plan have to be submitted to Senior Summit. And for Thailand, we can discuss about that, right? So that the plan can be synchronized. And then, but each country, they can have their own plan, right, according to their participants. And in the contract in each country, we put in the date by middle of January that they have to submit. But I think given this situation, maybe they need more time, right? So that means we would like to get this logical framework finalized first, so that it's stable, that this will be the group, right? And then when we get consultation, we each team is clear enough about the target group. I think in the plan there should be a clear definition of who will be your target group, right? So that when you decide the PD, you already take into consideration of the target group that you already discussed among your team, right? And then the country agencies that take care of the whole program also acknowledge that, or maybe they have some input that, oh, I want to include this into the target group. I think the finalization of the plan need also to be endorsed by the country coordinator. Yeah. And yeah, so yeah, we will. I think Dr. Burin, when after actually 23rd, when is the next one? The original, can you pull up the schedule?
Yeah, one moment, please.
Yeah, so that maybe we can try to see that is it possible that this finalization of the target group can be done within this date or not, right?
Dr. Brinda,
I
have
hope
any
that
questions?
Dr. Kesara, I hope that the deadline will be on February, because Dr. Wahyudi planned to meet Indonesian team in January, but I'm not sure whether in a third.
Okay.
Yeah.
Okay. So yeah, actually we plan to meet next time is 23rd. How about you think that when should be best according to this calendar, right? Actually, we plan to have 23rd, 24th, 26th. I originally planned that maybe we need to skip that and maybe postpone it to, how about like 30th of Jan should be our next session? You think will it allow you sufficient time for you to meet with Dr. Wayudi and finalize that?
Yeah, I'm not sure about the plan, the time of meeting of all Indonesian team, because I think Dr. Wahyudi had said that they will have a
Meeting.
yeah, in January, but he doesn't he have not mentioned about the
yeah.
exact date.
Okay, how about Kazakhstan? Let me maybe check one more country. And
Hello.
yeah, Doctor. Yeah, how about Darren? Do you think that?
I'm here.
Do you think that when should be best for how long do you need to finalize the target group?
So actually, we worked about our plan. We already. Do you remember at September we showed you?
Yeah,
So
you
I
already
think
got that, right? Yeah.
in the end of January, but we have just a little problem. We still didn't meet with our team members because we are in the different
So,
part of Kazakhstan. I mean, I'm in the south of Kazakhstan, so we just see each other here in webinars.
okay, yeah. So, okay, I will try to get in touch with each country project team, right? And then mail to them and then say that let's meet certain time so that we agree about the target group. And yeah, I really like to see that the PD team, you have the teacher in each team. For example, if you are going to deliver water quality, you will have teacher in your water quality team too, right? Because designing the PD for teachers, it will be very helpful if you have the teachers who actually teach and have the strong content knowledge and also teach in that area because it will help you think about when you deliver the training that related to learning activities. This teacher will and you will decide together about the PD activities. So I encourage that you will recruit teachers with content knowledge relevant to each learning unit in your team. And when coming to the design of the learning activities, their experience will be very helpful for you to decide the activity that fit in with the learning environment in a classroom. Especially when you need to write a lesson plan in details. Yeah, this teacher will their experience will be resourceful for you. Yeah. So how about if we try to schedule on the I think 30th of Jan. This one, so that maybe the meeting can be undertaken from you have so you have about like maybe 3 weeks, right? Let me see. Now it's 11, 1, 2, 3, around like almost 3 weeks to discuss, because I also don't want to leave it too long or else you will forget.
I think the end of January is okay.
Yeah, right. Yeah.
Okay.
Oh, January. Okay. Yeah, at the end of January. So let's schedule our next session to be on the 30th of January, and I will send email to Sarina, to Dr. Wahyudi. Yeah, and for Cambodia, we are meeting them in Cambodia next week. So I will communicate with the Cambodian team. Yes. Okay. Do you have any questions for me for Simeo STEM-Ed?
I have one question, please.
Yes,
So at first when planning the PD program, I was worried that the teachers have to use all the learning activities and all the units and see the results. I thought that was the expectation of Simeo STEM-Ed. So from what I heard from you and Joe, am I understand correctly that the numbers of the unit and or the numbers of activities doesn't matter. We can focus on maybe a teacher might use only one unit and adapt or adopt only some activities in that. That's fine too, right? If it fits their context.
Yeah, so I like you to think about if you are a researcher, right? If you want to study the effectiveness of this learning of these quality units, right? In some country, they might adopt full. Yeah, so I think this depends on the context. And I believe that if we are able to recruit but I like you to ask I like you to ask teachers first that what do they think about this learning unit. Because I think that if we invite the teacher leader from Sokovokor, right, from the IPST group, right, they might be able to work around because they want to learn from using the units as well, and to get the full benefit of learning units. So we would like to have teacher make decision based on what they think is best, without forcing them. But this has to be based on they really learn that this unit will lead to whatever result first, right? And then they can make their own decision. Maybe they can try, and then over time they can adopt the full one. So I think this the process that I used to do is that we try to recruit people who want to try it out. The full unit first but when they take a look, right, they may see, oh, maybe this one cannot because of the limitation of the time. But usually teachers who want to try it out, they will try to find time. They will but teachers that maybe have limitation in maybe the workload, the teaching load, right? They might say, oh, this fit in only this one, right? Yeah, I think you will find mixed approach from different teachers. Yeah. And yeah, we are fine if they cannot implement the whole thing. Yeah.
Okay,
Yeah,
thank
without
you.
forcing them.
I'll plan about this in more details. Thank you.
Yeah, thank you. And like I said, that we can help recruiting. We can talk to IPST that maybe they can recruit the teacher leaders to be, to be the recipient, or maybe to work with your team in designing the PD in the longer term. Yeah. Okay. Any more questions?
So next webinar on 30th of January, right?
Yes, that's right.
Yeah, okay, thank you.
Yes. And okay, I think we are done. We don't have any more questions. So thank you very much for your time. And look forward to seeing you on 30th and through emails, correspondence in the future. Thank you very much.
Yeah, thank you, Dr. Kestara, Dr. Buri.
Thank you.
Bye-bye.
Thank you.
Bye-bye.
Bye bye.
Thank you. See you.
Good night.
Another
Bye. Have a
Bye.
good night.
Bye bye,
Good
Moni.
night. Bye-bye.
Bye.
Bye. Good night.
Good night.